Well, it's coming on in the evening. I'm working as fast as I can. We are on normal distribution, problem number 10, and working these problems, hoping to help my students understand the why of what we're doing a little bit better. So here we go. It says, the scores of students on an SAT college entrance exam at a certain high school had a normal, very important again, distribution of mean equals 553 and a standard deviation, sigma, of 27.8. What is the probability that a single, key word right there, single student randomly chosen from all of those taking the test scores a 557 or higher? So again, it's very important to recognize the fact that we are talking about a single student, a single observation, okay? So we're standardizing a single value. And we want to know what's the probability that a single student randomly chosen from all of those taking the test score a 557 or higher. So let's tackle that to begin with. So here we go. So this is problem number 10, and we're going with part A. And we were given that the population average is 553. We were given that sigma is equal to 27.8. And part A says, what's the probability that X, in other words, a student that we choose at random, scores 557 or greater? Remember, it's okay if we leave it as greater than, or if we take and put an equal sign there. Alrighty, so let's draw a picture of what we're looking for. We put our mean in the center as 553, and we're going to put our 557 over here to the right because we go in numerical order as a number line would. And we're looking for the possibility of a student making greater than 557. So that means we're going to standardize our score. And so our formula to standardize our score is x minus mu divided by our standard deviation. And our x is right here. It says x has to be greater than or equal to, so we're going to put that value right here, 557 minus our mean of 553, 553 divided by our sigma of 27.8. And we put that in our handy dandy calculator, and we find out that that is equal to z of 0.14. So to draw our corresponding picture, oops, that was kind of crooked. Let's try that one more time. See if I can't do a little bit, whoops, do a little bit better. There we go. It goes like this. We put our mean in the center, and we're going to put our z right here is 0. My computer's getting hot. 0.14. And we're looking for this area right in here that z is greater than. So this is actually equal to the probability that z is greater than 0.14. And to find that, we're going to use our z tables. So we're going to switch screens here real quick. And our z is right here. We find our z by going through this column and this column, or this row. So 0.1, and then we scroll over to the column with the 4 in it. So this value right here, the area under the curve for z is equal to 0.14. So the area under the curve between 0 and 0.14 is equal to 0.0557, 0.0557. So we'll switch screens and we'll go back and we will put in here. This is the second time that's happened when I've come back. I don't like that. Hang tight. Let me find where I'm at here. There we go. Maximize that out. We'll shift it over some and down. There we go. So the area under the curve right here is point. Do I have it written down on a piece of paper? Let's see here. Yep, 0.557, because my memory gave out on that one. Right there. So right here is point, whoops. Is 0.0557. 0.557. So that's the area under the curve right in here, okay? And this is your mirror image. This is the standardized view of that exact same question. So that is the area within there. And the question is what area is under the curve, or what's the probability of having something in here? That's what we're looking for. That's the area right in here. So now what we can do is we can say that we know that this right here, the area that z is greater than 0.14, since we know that this whole half over here has to equal what? This whole thing over here has to equal 0.5. So it's 0.5. And if this whole area equals 0.5, if I subtract off this area here in blue, what do I have left? I have the area in yellow, which is the area that I need. So then I'm going to subtract off the area in blue, which is 0.0557, and that's going to give me the area in pink that I'm looking for, which is this area right in here. So we grab our calculator and we punch that in, and we find that that is equal to 0.4443. Okay, so that is the answer of what is the probability that a student selected at random scoring having a score of higher than 557 is equal to 44.43%. Okay, so let's go back and put that in our solution here. Okay, so we're going to put 0.4443 and check our answer. And it says we got it right. Good job. Okay, team, let's move on to part B. It says for part B through D, consider a simple random sample of 35 students who took the test. So part B, what is the mean and standard deviation of the sample mean score X bar of 35 students? The mean is, okay, so what we're saying is we're changing the situation up a little bit. And we're going to say, instead of looking for a single student, we're going to be taking a random sample of 35 students. And I want to know, we're going to be talking about the probability that the average of those 35 students that I randomly select, that their average is a particular value, okay? So we're looking at what is the mean of the sampling distribution for X. It's going to be the same thing up here as up here, the 553. Okay, it's going to be the same thing right there. And so we're going to put 553 right there, 553. So we'll check our answer. There we go, we got that right. And then it comes in, it says, what is the standard deviation for the sample distribution of X bar? So we're asking, what's the error about the mean? That's really what we're asking here. And remember, when we changed from looking at an individual single student to looking at a group of students whose average of all those scores averaged together is a certain value. Now we calculate that sample, the standard deviation of the sampling distribution a little bit differently. We take our standard deviation right here and we divide it by the square root of n. So let's go ahead and switch screens and do that calculation. So this is going to be part B. So let's grab some purple ink for part B. So we're going to put part B, and we're looking for what is sigma about X bar. That's the question. And that formula is equal to sigma divided by the square root of n. Well, we found out earlier that our sigma is 27.8. So we're going to use that 27.8 divided by the square root of n, which we had given in the problem was 35. So we're going to punch that in our calculator, and we find that that is equal to 4.6991. I prefer that we always go to 4 decimal places on this, okay? I know sometimes your homework asks you to only go to 2, but remember on the exam and stuff, I'm going to have it on there. I want to make sure you go to 4 decimal places. So we'll switch back to our screen, and we will put right in here 0. Not 0, sorry. It's 4.6991. Okay, so we will check our answer there. Check answer. Voila. Alrighty, moving right along. So now part C says, what z-score corresponds to the mean of X bar equal to 557. So we've changed the question. Here we want to know what's the probability of a single student randomly being selected and that single score being for that single student being 557. What we're asking down here is a completely different question. It's saying I'm taking a random sample of 35 students, and I want to know what is the probabilities, what we're going to be asking right here, the probability that the mean score of those 35 students, all averaged together, that average score is 557 or higher. Not one individual student, but the average of all 35 students, if their average score, what's the probability that that average is 557 or more. So that's what we're looking for right here. So what is the z-score that corresponds with that? So let's come over here and calculate it. So this is going to be part C, and part C is going to look like this. So with part C, we're saying what's the probability, it's written different, that X bar is greater than 557. Actually, that's probably part C and D together, okay? So notice right in part A, we don't have a bar above our X. We just say, what's the probability that X, because we're looking at an individual observation, is greater than 557. But for part C down here, we're saying, what's the probability that the average of all 35 students, that their average score is greater than 557. Okay, so we have an X bar up here. Very important, distinguishable difference. So we're going to mosey right along here. I'm going to rewrite a couple of values. I'm going to put that my mu for the population is 553 because I'm going to scroll up, and that my sigma for the population is 27.8, and that my sample size is 35. So I'm just going to scroll up a little bit so that I can work. So we have a new situation here with a new picture, and my new picture is going to look like this. We're going to have our standard curve. In the center, we're going to put our mean, which is 553. And we're going to put our X bar on here, which is 557. 557. And we're saying, what's the probability that X bar is greater than that? So now we want to draw a corresponding picture of 0 right there, and we're going to standardize that value, and we're going to find what does z equal that corresponds to this value right here, 557. So we have a different formula because we're dealing with X bar. So because we are dealing with X bar, the average, we use a different formula for z, okay? And our formula looks like this. It's going to be z is equal to X bar, not X, minus mu, divided by the standard deviation about the mean, which is sigma, divided by the square root of n. So that is what our formula looks like. So this is going to be equal to X bar is our 557. X bar is 557. 557 minus our mu, which is right here, 553. 553 divided by my standard deviation, 27.8, 27.8, divided by my sample size right here of the square root of 35. And when we put that in our calculator, it's going to equal 0.85. 0.85. And I want you to take and pause the video right now, and I want you to calculate that this is equal to 0.08. Oops, sorry. This is equal to 0.85, okay? Because this can be tricky. You should probably use parentheses around the denominator, because if you don't know how to use your calculator by the time you come in for the test on Thursday, you're going to have some challenges there. Okay, so I'm going to bring up TI-84 and show you how to put it in a TI-84 real quick. There we go. But many of you don't have a TI-84, so it just depends on what type of calculator you have. So here is the TI-84 being used for this. So I would open up with parentheses, and I would go, because I want the numerator here to be captured. Okay, I want this numerator here to be captured very clearly. Let me change my colors here. Let's see here. I don't have yellow. I guess we'll do purple. Okay, so bring my calculator back up. I want my numerator here to be captured within the parentheses, because otherwise, if I could end up with just 553 being divided by the denominator here and losing the 557. So I'm going to open with parentheses, and then I'm going to come and I'm going to click 557, and I'm going to put minus 553. Now I'm going to close the parentheses. I'm going to hit the divide sign. I'm going to open parentheses again, and I'm going to put 27.8 divided by, I'm going to hit up here, and let me get mine closer to me so I can see. Oh, sorry, that's above the x squared. My computer's a ways away from me. Is that right there? Nope, I guess not. Let me tilt my screen so I can see my good old eyes. Let's see here. Let's just clear this. Okay, there we go. So 27.8 divided by the square root of 35. So it's going to be second and right here. And that's going to give me 35. I'm going to hit this to come out from underneath my radical. I'm going to hit my parentheses and hit equal. Okay, so as you can see, I get 0.85. I only went to 2 standard deviation or 2 decimal places because my tables only go to 2 decimal places. So there's no point in me going further because my tables don't go any further. Alrighty, so that's how we get the 0.85. I do have another calculator on here. Let me find that real quick. And we'll just start this one up. I'm sure it works about the same way, but let me just, yep, I'm not activating my license yet. I'm still on my free trial. Okay, so here is our other option for calculating. So we'll put this here, we'll put this over here, and we will cruise that right over there. All right. So again, I would open with parentheses, and I would go 557 minus 553, close parentheses. I would hit divide, and then I would go parentheses 27.8 divided by my square root, which is second, and this one right here, because there's my little square root button symbol right there, so that's why I have to hit the green second button. And now I'm going to put 35, and now I'm going to come out from underneath that, and I'm going to close my parentheses and hit enter, and I get the same answer right there, except for my cursor now is off on my tracking, which is not good. Okay, so back over here. So that's how we get the 0.85. Was that the question that we had to answer? Please tell me yes. Yes, so we're going to put 0.85 and check our work. So there we go. We have that correct. And the last part of my question is, what is the probability that the mean score X bar of these students is 557 or higher? So again, we're asking, what is the probability that the average score of all 35 students is at least a 557 or higher? So to find that, we're going to come back in here, and we're going to search and solve for the area under the curve right here, because that's the probability that a score, the average score, is 557 or higher. So we're going to look in our tables for 0 to 0.85 and find this area right here. We'll highlight this area in blue, and we will go find that value in our tables. Okay, so let me get over here to our Z tables, and we are looking for our z of 0.85. So 0.8 is right here, and 0.5 is right here. So we're going to look for the intersection of the two, and it is right there. Okay, so there's that, and whoops, there's that. Alrighty, so our value is 0.3023. So 0.3023. Oops. We got to switch right here. There we go. Alrighty, so right in here we have, pull out my stylus, I put it back into charge while I was talking to you. Okay, so we'll come up here and select a pin. So we said it was 0.3023. So 0.3023. Alrighty. So if I want to find what is the probability, so for the last part here, the probability that x bar is greater than 557, which also equals the probability that z is greater than 0.85, that is going to be equal to 0.5, because right in here, let's see here, this whole area right in here, all of this area right in here is equal to 0.5. So let me see, can I find a yellow pen? I can find a yellow pen. So that is equal to 0.5 minus my blue part right in here. So we'll grab our blue pen of 0.3023 is equal to this last area right in here that I need it to equal to, which is 0.1977. So this area right in here is equal to 0.1977. Or right in here, same thing, 0.1977. So that is our answer, 1977. Good year. So let's come on over here and put in 0.1997. There we go. So what's the probability that the mean score of x bar of these students is greater, it's 557 or higher? So basically a 20% probability that the average of 35 students, of that their average score, all averaged together, is 557 or greater. And there we have it. If you have any questions, I do hope that you will take and send me an email and ask. I hope this is helpful and beneficial, and have a good day.